let's talk about the term. What is soft shut-in? Soft means what? You are not having hard impact on the well bore pressure. You are not having hard impact on the well bore pressure. Remember, whenever you shut the well, it has to be in a softer manner. You should not create any hammer effect in the pressure profile in the well bore. Okay? That is soft shut-in. Now soft shut-in, what we do? The fluid is passing this way. Very first thing what I do, soft shut-in. I stop drilling. I stop drilling, right? Long back. I stop drilling. I check the flow. Flow is coming. The well is flowing. So what my first thing is what? What should I do?
Controlling the flow.
Shut-in. Talk about soft shut-in now. First thing you do is, in normal drilling position, for that you need to understand what happens in normal drilling position. In normal drilling position, this HCR, what is HCR? Hydraulically remote controlled valve. The same valve we are talking about, hydraulic valve. Okay. In normal drilling operation, that HCR is in closed position. We don't want mud while drilling to go into the choke, na?
Yes.
While drilling, it has to come up and go back to the tanks. So HCR is closed, but manual valve is kept open all the time. Only in case of emergency, you will close manual and then repair whatever. If the choke line is burst or whatever, whatever repairs you can do later on. If the manual valve, you can close it. But the point is, in normal operation, in drilling operation, HCR will be always closed. Okay? So for lining up for soft shut-in, now I am doing soft shut-in. How I am going to proceed? Before closing BOP, I am going to open HCR. Once I open HCR, the fluid has got a path to pass already if the BOP is closed, right? Now, where the fluid is going to go? I don't want to impact the well, right? So, again, this choke, that should also be open. At least it should be partially open. Halfway, you can call it. 50% open, 100% open, doesn't matter. Up to company policy. Okay? But this should be open in soft shut-in. Remember. Then I close the BOP. Which BOP? Annular, ram, which BOP? Why you prefer annular?
You can easily resume afterwards.
Nothing like that. You can use any BOP. Okay. Any BOP is okay.
Flow to be running.
It is up to your. Sometimes companies, they are very stringent. They make policies for this. They will say, okay, now you have to close pipe ram. The reasons behind there are many reasons. See, if you are drilling in very high permeable zone, okay, the kick can enter very fast into the well bore at very high speeds. So you will have a lot of kick volume in the hole before the well is completely shut in. Okay? In high permeable kicks I am talking about. Annular takes practically around 35-40 seconds to close. Okay? Pipe ram takes 5 seconds to close. Which will you prefer?
Pipe
ram.
Good answer now. Okay. Prefer whatever is best. Up to you. You can use any ram, not a problem. And if I close the pipe ram, company man says, "नहीं यार, मेरे को pipe ram पसंद नहीं है. I don't like pipe ram." If he wants to close annular, welcome. You can close the annular also. Once if that's the policy. Okay. Doesn't matter. But now the BOP is closed, right? Now BOP is closed. Now which way the fluid is expected to pass? This way? It is already passing through that. Because there is no other way. The kick is still entering, it is still coming in. Now what you do is, you close the choke. So you have not given any kind of hammer effect on the annulus. Okay. Now you close the choke. Now what happens? Now you close the choke. So this complete annulus is completely closed now. It is isolated. Okay. On the surface, because you were drilling, so on the surface everything is connected to where? To the mud pump. So that line is already secured. It is not leaking somewhere in between. So there will be reading on the standpipe gauge, right? There will be reading on the drill pipe gauge. There will be reading on the casing gauge here. You got both the readings now in your hand.
Yes.
Okay, you can kill the well. I don't need to be here from tomorrow onwards, right? Okay, you got the point.
Yes.
How you get the reading? How you get? This is called as shut-in drill pipe pressure. What you see on drill pipe, that is shut-in drill pipe pressure. What you see here is shut-in pressure. So you know everything already, right? Okay. Once you close the choke, then only you will get these pressures. Otherwise, it keeps flowing. Yeah?
Yes.
This was about soft shut-in.
Soft shut-in.
You understood how the soft shut-in is.
Yes.
And before soft shut-in or hard shut-in, you were drilling anyway, right?
Yes. So
In drilling, positions of choke, they matter. What is your company policy to shut in? If the choke is kept half open or full open, that means you are following soft shut-in. Now let's come to hard shut-in. In hard shut-in, same thing. This setup doesn't change.
yes.
Manual will be
Closer to
open all the time. HCR will be,
close.
right now it is closed because I am drilling. Now, what is position of choke? If my company says you have to line up for hard shut-in, what is position of choke here? It should be completely closed. Okay. So simply by looking at choke position, you can tell if your policy is hard shut-in or soft shut-in while drilling, right? Okay. Now, how the hard shut-in is going to happen?
Same as
Hard shut-in, there is change in procedure, only a little bit. Only the sentences move up and down. What we did here first, we opened the HCR and then closed the BOP. Am I right? Now in hard shut-in, first thing what you do is arrest the flow in the well. First thing you do is close the BOP. Okay? HCR is closed anyway. Now you open the HCR. This is already closed. In hard shut-in, this is already closed. Straight away, read the pressures. That is hard shut-in.
Yes.
Clear?
Yes.
Okay. Any doubts in this? All clear?
Yes.
All clear. Good. Now sometimes there will be float in the string. Now what is float? Any idea? तुम लोगों ने फ्लोट देखा यार? लैब में बहुत सारे पड़े हुए हैं उधर. कोई देखता नहीं है उसको ना. लैब में कौन जाएगा? अपना काम थोड़ी है. What is float? There is float in the string. There is NRV in the string. When you pump, non-return valve. NRV is non-return valve. Yes. You can pump through, but nothing can come back. It's spring operated, right?
Yes.
So float collars, that is different. See, in drilling, you will install this small piece of equipment in where? In bits up. In bits up. In conventional, it will be in the bits up. Otherwise, it will go above the motor and all that. But motor वगैरह, उसके ऊपर जाएगा. If there is float in the string, what is the problem with this now? If there is float in the string, what is the problem? Can I go for hard shut-in? Can I go for soft shut-in?
You can go for soft shut-in, but anyhow because of NRT.
See, I have got a kick. I have
but
got a
that
kick.
kick actually stopped by NRT. It is not going to be affect your system.
Another flow will be happening. Float is in the drill pipe.
Float is in the drill pipe, of course, yes.
Another kick will be happening. Kick from
Kick is always in the annulus.
Yes. But it doesn't specify which soft or hard.
No, no. Tell me, what would be your option? If there is float in the string, what is your option? You will go for hard shut-in or you will go for soft shut-in? Why?
Missing data.
Missing data. Which data is missing? Which data is missing?
You can process it.
Tell me, what would you prefer? If I am on the rig, for me it doesn't make any sense here. Come on. If there is float in string, let it be. If I follow hard shut-in, I follow hard shut-in. If I follow soft shut-in, I follow soft shut-in. Simple. That doesn't matter what is in the string. Okay. What matters is you will not be able to read SIDP. Why? Why? That pressure will be arrested into that float.
Yes.
Yes or no? The pressure will be arrested into the float. Casing side, you have no problem.
Yes.
You are ready straight away, right? But the pressures on the drill string will be arrested down in the float.
Yes.
Now, how to read? See, this SIDP is very important for us in killing the well. That we will see tomorrow.
Yes.
Today we got connected all the data, right?
Yes, sir.
Tell me, how will you read SIDP? यार गूगल मत करना लेकिन मेरे को रिस्क यही है तुम लोग रात को जाके गूगल करोगे अभी How will you read SIDP? If there is float in the string, as an example I am just telling you, क्या फिगर करूँ? अरे क्या है क्या है? See, it is like this. I am telling you. This is the well. This is the well. This is the drill pipe. This is the bit. Okay. This is the BOP here. You have closed the BOP. Correct. Okay. Now this casing gauge. This casing gauge I am showing somewhere here. Guys, listen carefully. This casing gauge I am showing here. You can read the casing gauge. That float is somewhere down here. Okay, it's a kind of flapper, or sometimes it's a arrow kind of a small, poppet type of thing. So that float, as something wants to come up, that float is going to shut in at its seat. So nothing can come up now. So there won't be any pressure reading. Something is pushing down below, right? On this side, whatever is there, you see on the casing gauge. What about drill pipe now? How I'm going? There is one drill pipe gauge on my, say, mud pump or standpipe or wherever.
When peak happens, we'll stop the pump. So the pressure on that pipe, it will decrease.
Which pipe?
On drilling.
That will become zero. Huh?
Yes.
So
Then it will not. That reading itself tells us that float is there.
ma'am, the formation fluid has entered into well.
So the casing pressure is there.
Casing pressure is there. What about drill pipe pressure? Try to understand one fundamental. Forget about this diagram right now, okay? Before kick, okay? Before kick, this was the well before kick, correct? What was hydrostatic pressure at bottom on casing side? Was it equal to what was on the drill pipe side? Yes or no?
Yes.
Whatever is in the drill pipe, it's in the same thing in the casing.
Yes.
So hydrostatics, now think this as a U-tube. Think this as a U-tube. This is the U-tube. This is the U-tube. Now, is the U-tube equal during drilling?
Yes.
It is. It is equal. Forget about that cutting part and all that. Okay. Forget about it. It is equal. 10 ppg in the drill pipe, 10 ppg in the casing. It's equal.
Yes.
The U-tube is equal.
Yes.
If I stop the pumps, it doesn't flow. It's static. Both the limbs are static. When you get a kick, what happens?
Casing side will
Casing rises.
There is influx in the casing. This was 10 ppg. In the drill pipe was 10 ppg. Now what has happened is this part is 10 ppg. but this part is 2 ppg. Now what is happening? Which part is heavier now? Which limb is heavier? Which limb is heavier? Drill pipe or casing? Which hydrostatic is more?
Casing side hydrostatic is more because of it.
I am talking about hydrostatic pressures on both the limbs. One limb
Hydrostatic pressure.
is, see now I am drawing YouTube straight away. This is the YouTube. This is bit. On casing side, this is 2 ppg, rest is 10 ppg, and on drill pipe side, this complete thing is 10 ppg. Which limb is heavier hydrostatically?
10 plus 2. 10 plus 2. Yes. This side is heavier. Yes. Yes, that's 2.
Sir, right hand side should be equal, right?
I have to move it little bit away from the camera.
It has to be equal.
Okay, but tell me, which is heavier and which is lighter?
Right hand side.
Right hand side is what? Okay, now we have to do a numerical before T. I'm sorry.
That's what we need actually to understand.
Come on, go ahead. Now I'm giving you actual numbers.
Yeah. Okay.
Well depth is 9,000 feet. Well depth is 9,000 feet. Okay. You got influx of 600 feet. This is 600 feet. Huh? You got influx of 600 feet. Calculate hydrostatic in both the limbs now. Separately. I've दिखाया है 10 ppg है. This is 10 ppg. This is 2 ppg. How you calculate hydrostatic? दिया ना कल फॉर्मूला दिया है 0.052 into 10 into 9,000 कितना हुआ? Four six 80. Which side? This side or this side?
Right.
This is 4680. PSI. PSI. इस साइड कैलकुलेट करो. 312 PSI. How? Tell me how.
What is it?
Tell me how.
9,000.
Huh?
What was it?
9,000 feet, na? Well depth.
And 600 was?
600 is height of this section. कितना है ये? Come on यार. How you guys are doing 10 plus 2? What is 10 plus 2?
No, it's not 10 plus 10 into
Alright, there is difference in density, man. Come on. This section has to be calculated by 10 ppg. This section has to be calculated by 2 ppg. Do it. Simple.
873. Yes.
नहीं यार 870 it cannot be that low.
312.
312 क्या है?
Yes.
Including this and this. Tell me, including both.
That's why I have to
4
You guys are amazing. Total कितना है? 4 4 3 0. Now which is lighter and which is heavier?
Casing side is lighter and
Simple yaar, come on. Why you are saying casing is heavier, casing is heavier?
Why? The question is why?
Why you are doing 10 plus 2? Come on. 10 is 10. 2 is 2. There is no 10 plus 2.
Yes.
So now what happens? Let's talk about it. YouTube.
Yes.
This is YouTube, right? Now which side is heavier?
drill side.
Right side.
Right side is heavier. This will try to push down this side or not. It is heavier. It will try to compensate itself at some level, no?
Yes.
Now whatever is the back pressure from this side, you will see on the
Casing.
casing gauge. You got my point?
Yes.
But there is again one but here. It's not the tussle between only this side and this side. It's not only this happening, right?
Yes.
Who is pushing all this? It's somebody is pushing it down into here. Correct?
Yes.
So whatever is the underbalance on this side, it will be compensated not from this side. It's trying to compensate from here.
Okay, yes.
Okay? And if it trying to compensate from here, it will enter both the limbs.
Yes.
It's not, see, your YouTube is connected, man. YouTube is connected. So whatever enters from down into the formation into well bore, it is going to affect both the limbs.
Yes.
But one limb will be affected more because it is on lower side.
Yes.
One limb will be affected lesser because it is on higher side. So you will have SIDP as well as SICP. Now this cannot, SIDP cannot be zero. My question was, if there is float, how you are going to read the pressures? Now you can tell me this thing tomorrow. Okay? If there is float in the string, how you are going to read the pressures?
Okay, sir.
SIDP, yes. How you are going to read the pressure? Unless you read that pressure, you cannot proceed for the calculations. Simple. Correct? Arey, one more thing, yaar. Tomorrow we will need kill sheet. I'll give you some format. Can you get printed?
Yes.
Take 15-20.
Horizontal, vertical.
हाँ?
Horizontal or vertical?
हॉरिजॉन्टल क्या करोगे यार? अभी तो YouTube नहीं समझ रहा है यार मेरे भाई, प्लीज. No horizontal, only vertical. Let's get into basics first. ठीक है? Okay? Yeah? चलो.